In this tutorial, we're going to look at how to use probe for EPMA to apply multiple conditions to your analysis points. There are several reasons why you might want to do this. For example, you might want to repeat analyses at multiple conditions. So for example, you want to require analysis points at a range of voltages for thin film analysis. And on another mode, you may wish to apply different conditions to a single analysis point, for example using different beam currents for major and trace elements. We're going to cover examples for both of these. In this first example, we're going to look at how to repeat analyses at a range of accelerating voltages. So for example, we'll set this up to run at 5, 7, 10 and 15 kV. So we'll start by setting up a new sample, and we'll call it 5 kV because that's going to be the one we're going to start at. And we click OK. We go to elements and cations. I'll just do a simple copper on iron sample. So we put copper in. Now K alpha has quite a high energy, so we're going to use the L alpha line so that we can run it at the lower voltages. We'll just choose tap crystal for that. And iron, again we're going to use the L alpha. And the tap crystal for that. Now we go to the analytical conditions. Now here we want this to run at 5 kV, so we put 5 in. And you can set what other values you want to do as well. So let's assume we want to do this at a 10 micron beam spot. And we'll do it at 10 nanoamps. The instrument will then go away and set those conditions. And that's the instrument ready to do any analyses. But we won't be doing any analyses at this point. Now, I'd assume that you would be doing checking your peaking and your PHA settings as required and that those are correct. Now, before we do any analyses, what we're going to do is we're going to set up a new sample. And we'll call this one 7 kV. The elements and cations will be the same, so we don't need to change those. But what we'll do is we'll go to the analytical conditions and we'll change that to 7. Click OK, and the instrument will now set those conditions. And we'll repeat that for the 10 and 15 kV as well. And finally for the 15. Now we're going to need to run calibrations for these, so we need to load our standards as well. So we go to add remove standards, and we'll use the iron metal and the copper metal. Now if we go to analyze, we'll see from our unknowns that we have our 4 voltages set there. They've got an asterisk against them because they've got no conditions set. But what we want to do is we want to use those conditions to set up for analyses of multiple samples. So we click on the first one, and if we double click on it, we'll see that the kV is set to 5. Now if we click to sample setups, it'll then add that to the list of setups that are available for further analysis. Repeat that for 7 kV. And the 10, just confirming that they have taken up the correct voltages. And I'll close this window just to make things a bit clearer. Now we can go to automate, and we can start setting up positions. So we'll go to our sample. Let's digitize a new sample, and we'll just do a shotgun of 6 analysis points at this current position. Now what we're going to do is we're going to automate acquiring the standards and the unknown. So if you go to all samples and click select standards, it'll select the 2 standards. And then in the list we've also got our unknown sample that we set up. So if we hit control and click that, it's now got selected our standard calibrations and our unknown. And we just click acquire standards and acquire unknowns, and it'll do the standard calibrations first and then acquire the unknowns. Now what we want to do is we want to apply multiple setups to these. So we click multiple setups, and it now gives us our list of available setups that we've stored. So we want to run them at all 4. Now there's several settings here that we can vary. So we've done this in increasing kV, that's the order we've stored them in, but we have the option to reverse the order. So if we did want to run them at high kV first, you could do that, but we'll run from low to high. You can also choose to increment each set of conditions in the y-axis, and that means that you're not analysing exactly the same point for each condition. So for example, if you're worried that you've got contamination build up and you wanted to do a fresh analysis point, you can do that. Finally, you have the option to decide whether you're going to run all the analyses at one condition and then repeat the analyses at the second condition, or to switch between the conditions at each and every analysis point. We're going to leave that deselected. So we click OK, and it asks us to confirm that we're wanting to run multiple setups for those samples and standards. Now at the moment our standard points to acquire is 6, I'll just reduce that down, and our standard Y increment is 5, but we've set a beam size of 10, so let's increase that to 10 as well. And down here you'll see that the mode is use digitize multiple setups. So that confirms that multiple setups have been applied. It tells us that we're doing 2 standard positions and 1 unknown position. We could obviously run several unknown positions and it would automate that as well. The total time is going to take about 46 minutes. So I'll set that to run, and we'll come back when the analyses have completed. So the automation is now completed, and if we look at analyze, we can see under standards that we've got 4 sets of copper metal calibrations and 4 sets of iron metal calibrations, and if we double click on the first one, that's at 5 kV, second one at 7 kV. So those are the accelerating voltages. And if we go to our unknowns, we've got 4 sets of our unknowns run at the same positions. If we double click on the first one, that's at 5 kV, and that one's at 7 kV. Now it hasn't appended the voltage to the voltage condition to the sample label because that's the position label that we've given the sample. But what we can do is we can click on that and we can click on name description. And we can edit this to say that one's 5 kV. Seven. And 15. We could now go and export those for our thin film analysis. In this second example, we're going to set up for a major and trace element type analysis, where we want to measure the major elements at a lower beam current and the trace elements at a higher beam current. We start this in a similar way to how we did the multi-voltage analysis, in that we're going to save some sample setups. In this case, we're going to save the major elements first. So I'll delete the elements we have in there from the previous example, and we'll start from scratch. So in this example, I'll just use 1 element for each. So we'll put iron K alpha, and we'll put that on spectrometer 4 on the lift crystal. Again, you would do your peaking and your background settings and your bias measurements, etc. I'm going to assume those are all correct. Now there's nothing to stop you doing more than 1 element for your majors. You can do anything up to a complex silicate analysis where you have a dozen majors and a dozen trace elements. But I'll just show 1 element just to show you how to go through the procedure. We already have our standards loaded from the previous one. Now we go to the analytical conditions. Let's set it for 25 kV, beam current at 10 nanoamps, And let's leave the spot size at 10 microns for this, just to show that you can change any of these conditions between your two analyses. And we'll say OK to that. The instrument will now set those conditions. We'll then set another setup for the trace elements. And this time we'll delete the iron, and instead we'll put copper. And we'll put that on spectrometer 5. We could put it on spectrometer 4, it doesn't matter. Now we'll still do this at 25 kV, but there's nothing to stop you doing this at a different accelerating voltage. We'll up the beam current to 50 nanoamps, and this time we'll change the beam size to 1 micron. And we say OK. And again, the instrument will set those conditions. So if we go to Analyze, and from our unknowns we can see we've got our majors and our traces. We double click on that, it says 25 kV, 10 micron beam with a 10 nanoamps. Add that to the sample setups, and then the traces is now a 50 nanoamp beam with a 1 micron size, and we'll add that to the sample setups. Now we've got a choice here. We could set up a new sample condition, which would be all elements. And here you see load multiple setup. And you can see that we have our majors and our traces, and we could block select those. You see we can also reverse the order that it loads the settings in. Now the other two options are greyed out. Now the reason for this is when we set up using this method, each sample is going to have both the majors and the traces. So when we run multiple acquisition points, it'll run both conditions at the first analysis point, and then it'll go to the second analysis point and run both conditions. If we click OK there and OK there, we now look at the combined conditions option. We can see we've got the two conditions set, iron at 10 nanoamps and 10 microns, and the copper at 50 nanoamps and 1 micron. And it's going to do it in the order of iron first and then copper, so the first condition then the second condition. And we can see over here is a schematic of doing the iron first, a red bar to show we're changing the conditions and the time it's going to take to do that, and then the copper analysis. Now using these up and down buttons, we can change the order that these conditions are run in. And if you've got multiple elements, you can mix and match how you do each element within each set, as well as changing the entire set condition. The other way to do it is if we go to Automate and we digitize a new unknown position. I'll just call it all. Add new unknown. Again, we'll do 6 points in a shotgun. And again, we'll go to all samples, select standards, and then control to select all. And again, we'll go to multiple setups. Now we have the option to do these multiple setups on several samples. And again, we have the option to run multiple setups one at a time. And this time we'll select that to show the difference. Confirm that we're applying those setups. And again, let's acquire the standard and the unknown. And again, use multiple setups, digitize multiple setups. And this time it's going to take 21 minutes. So we'll set that running and we'll come back in 21 minutes. Our analyses are now completed, So let's close the Automate window and open the Analyze window, and we can see we have two entries for all. If we double click on the first one, we've got the iron analysis at 10 nanoamps, and if we double click on the second one, we see we've got the copper analysis at 50 nanoamps. Now we want these two analyses to be combined together to give us a single analysis of our majors and our traces. So if we select both of them, and then over here we have combined the selected samples into a new sample. There's also an option up here to combine selected samples. The difference between these two is this will temporarily combine them for a single analysis, whereas this one will actually generate a new sample from those two. So we'll select that one. We'll ask to confirm, and we now have a combined analysis. And if we double click on that, we see we've got both the iron and the copper analysis. And that's how you do the different types of combined analyses.